Hello and welcome to lesson 7-4. This is about arcsines, arctangent, arccosine, and trigonometric equations. Our objective for this lesson is to find algebraically or numerically the solutions for equations involving circular or trigonometric sines, cosines, and tangents of one argument. Now to start with, remember that in chapter 6, we have something like this equation. If you still remember, okay, we are actually familiar with this now. If we have a certain number, like for example 2, and let's say in particular a number a constant a, okay, now to find the particular solution for this element or for this constant, what we do is to get the arccosine. So remember, we do like this: arccosine -1, cosine -1, or arccosine of a plus 2 pi n, where n is any integer. Okay, z is the set of all integers. So this is what we did last chapter. Okay, in this chapter we are going to deal more on these sines, tangents, and cosines, and their arcsines. So below are figures representing these three important trigonometric functions. We have arcsine, arccosine, second one, and arctangent. So how do we do, or do we find an arcsine of a ratio, or an arcsine of any given argument? And how do we find the arccosine of any argument? Let's consider this first coordinate system here. That coordinate system, let's say we have x, y axis, and this is, let's say we have arc sine in this case. So we have an angle which is equivalent to arcsine. Okay, let's say arcsine 3/5. Okay, so how do we graph, or how do we find the angular measure of this arcsine 3/5? Remember that when you say arcsine, arccosine, arctangent, these are angles. Okay, these are not ratios of, I call this ratios of the coordinates. For example, y or x over y, but these are angles. And when we say angles, they actually came from a certain solution. So let us have sine y, or sine x instead, is equal to 3/5. Now to find the angular values for x, wherein sine x is equal to 3/5, we have to get the angular values, which are the x's themselves. And if they are given on a certain interval notation, then we will also have those x values which are limited in terms of the intervals they are following. So what is arcsine of 3/5 here? Note, I wrote sine here, but instead I wrote cosine on the other hand. So we have sine here. So how do we find, or how do we measure the arcsine of 3/5? First thing that we have to do is to determine or identify first what is sine. Okay, if you remember from the very first introduction to trigonometry, we have SOCA TOA. And the first three letters here indicate definition of the sine function, wherein sine is equal to opposite over hypotenuse. So in this case, our opposite then would be 3 and our hypotenuse would be 5. And that means that we have to measure also a certain specific triangle relating to this sine function here. So where is 3? It's on the opposite. So where is the opposite? The opposite lies here, right? Considering, for example, that is on the first quadrant. So that is the opposite, okay? And the hypotenuse will be the line which extends from the center going to that particular point. So this will be our hypotenuse, okay? And definitely the one here below or on the x-axis would be the, what do you call this? This is our adjacent. So where is the sine of 3 over 5 located? It is located here. This is actually our arcsine, or in other term, this is sine -1. That means it's arcsine 3 over 5. Okay, all you need to do is to extend or draw the length. This is worth 3 units, and this is 5 units. That makes it the arcsine of the angle, okay, or the arcsine of 3 over 5. Now it has a certain, what do I call this? It has a certain, another pair of arcsine 3 over 5, and you can find that pair by getting the reference angle, because when you say arcsine of 3 over 5, there are two angles actually rooting for that. We have in quadrant 1, right? And we also have in quadrant 2. Because as you can see, sine or arcsine 3 over 5 is positive, meaning we have two values of angles, which will be equal to arcsine of 3 over 5, which is in quadrant 1 and in quadrant 2. Understood? Okay, let me clarify it again. We have two values for angles, or for x, because x is an angle, and we have two values of arcsine 3 over 5, because as you could see, our arcsine 3 over 5 is positive, and in this coordinate system, we have two values of angles, which makes the sine of x as 3 over 5. Okay, and that is in quadrant 1 and in quadrant 2, where sine of x is 3 over 5. Okay, we cannot choose quadrant 3 and quadrant 4 because our quadrant 3 and quadrant 4 we have negative values of sines. So therefore, we will extend that. We will find a certain reference angle which is equal to sine -1 of 3 over 5, and that would be here. Okay, so after that, we can now place this line going there up to here, and we have another angle defined now for our arcsine, and this is equal to pi over, definitely this is equal to pi minus sine or arcsine of 3 over 5. So this is how we get interpretations for the two angular values, which are x is equal to arcsine of 3 over 5 and x is equal to pi minus arcsine of 3 over 5. Okay, so there are two solutions in there. What are the solutions? We have x is equal to arcsine of 3 over 5 and pi minus arcsine of 3 over 5. These are the two solutions. Okay. Now let's go to getting arc cosine. Let's say we have arc cosine of 3 over 5. And following the definition of the cosine function, our cosine is adjacent over hypotenuse, meaning the given 3 here will be for the x, or the adjacent angle, and 5 is the hypotenuse. So with that in mind, we first have to draw, okay, the length of our adjacent side, which is from here going to here. Let's say this is 3 units. And then we will draw the hypotenuse. So hypotenuse is, let's say, 5. Okay? So in that case, this will be our x, or x1, which is actually equal to cosine, or arccosine of 3 over 5. And how did we find that? This is 3, this is 5, so this is our arccosine of 3 over 5. Okay. Now we cannot use the same angle for the quadrant 2. Suppose this is, let's say, y-axis and x-axis, and there are two values of arccosine 3 over 5 here. The one yielding positive cosine x is equal to positive 3 over 5, and that would be in quadrant 1 and in quadrant 4. Okay, we cannot use quadrant 2 and quadrant 3 because in these sides your cosine is negative, which definitely contradicts the cosine function value here, which is positive. Okay, so in that case we can reflect this triangle here. So let's reflect it. Let's reflect here, and it has the same angular measure as, you know, the given positive, or the given arccosine -1 in the first quadrant here. Okay, so this is also the value of arccosine 3 over 5, and this value here, this angular measure here, is actually this. Okay, this is actually negative cosine, or negative arccosine of 3 over 5. So this is the value for the arccosine. We have opposite pairs. Here we have supplementary pairs, meaning we have one value, which is arcsine of 3 over 5, and the other value is a supplement of this value, because look that this value is also equal to this reference angle here. Okay, while in this case we have two opposite pairs. We have a positive pair and a negative pair, and both of them will yield a positive cosine x of equal to 3 over 5. Now how about the last example? Our last coordinate axis here is actually for tangent. And when we say we have tangent of, or arctangent instead, of 3 over 5, now take a note that this came from the definition of the tangent in the SOHCAHTOA, meaning the 3 here is the opposite and 5 is the adjacent. So this is our opposite and this is adjacent. And so we could draw our arctangent angle by means of getting, or finding the length of this, what do you call this ratio here on the coordinate axis taken or placed here. So we have opposite as 3. So where is our opposite? That would be 3. And our adjacent angle is 5. So let's do the adjacent first. And our adjacent will be here. It measures 5. And also we have the opposite, which measures 3. So it would be like this. Okay? And so we could draw the hypotenuse. So it's the hypotenuse then. And then now, this angle here is what we call the tangent or arctangent of 3/5. Okay? And that pretty much is obtained also by reflecting, because in tangent, both quadrants 1 and 3 share the same angular signs for the same signs for the angles. So quadrant 1 and quadrant 3 yields positive tangents, and quadrants 2 and 4 yield negative tangents. In this case, we have a positive tangent, and that is 3/5. So the angle must then be, its vertical angle, which lies there. So we have to get, okay, we have to reflect. We have to reflect another angle here, which is the same size or the same length of the sides as the one in quadrant 1. So it would be like this. And so this will be tangent of -1 3/5 also. Okay, but how do we get the measure of this one? So to find the measure of this, we have actually this tangent here is actually pi plus tangent -1 of 3/5. So we have two values of angles, which are the axis of the given trigonometric equation, where these angles are similar in the what do you call this, in getting the tangents, the trigonometric functions for 3/5. For example, these two angles yield the same results, and so on. Okay, so in this case, for number 3, or x will then be, we have tangent -1 of 3/5 and pi plus tangent -1, or that's arctangent 3/5. Okay, on the second example, the answer here for x would be equal to cosine or arccosine of 3/5 and negative arccosine of 3/5. Okay, so this is the general solution. I mean, these are the solutions for specific types of trigonometric equations. Okay,